Let's talk inequalities. We've done a lot with equalities, meaning we have an equation where 3x plus 5 is equal to 12. And we can solve for x in that scenario. In equations, we're looking at where both sides are equal. And so we're trying to keep both sides the same. In an inequality, we're not looking at where it's equal. We want to see where one side is greater than the other side or less than the other side. So if we're going to manipulate an inequality, we just have to make sure that we keep that less than and greater than. And so when we're solving, you really can use most of the same rules, but not exactly the same rules. So using the example that we just had, if we have 3x plus 5 is equal to 20. To go ahead and solve for that, we're going to subtract 5 from both sides. That gives us 3x is equal to 15. We can then divide by 3, and x is going to equal 5. Well, we can do the same thing. In fact, if we were to change all of this, let's take our equations out completely, and let's say we wanted to look at where it's less than. In this case, we would be looking at where x is less than 5, and if we plug in, for example, 3 is less than 5, so we should be able to plug a 3 in here. 3 times 3 is 9, 9 plus 5 is 14, and that is less than 20. So we've kept it unbalanced. The problem comes, let's change this to a negative 3x. Well, let's go ahead and just solve this the same way as if it were an equation. So we're going to subtract 5 from both sides again. We're going to do everything exactly the way we just did it. This time, though, we're going to divide by a negative 3. That gives us then x is less than now a negative 5. So we should be able to plug a negative 5 into here. And in fact, let's just pick a number that's less than negative 5. So let's say negative 6. Negative 6 is less than negative 5. So if we plug a negative 6 in here, negative 3 times negative 6 is 18, positive 18, plus 5 is going to be greater than 20, and so this is no longer accurate. And the problem comes right here. Let's just take something that we know to be true. If, let's say we have 3 is less than 5. Now that's obviously the case. If we were to divide both sides or multiply both sides by a negative number, you'll notice that now changes. Negative 3 is not less than negative 5 because of what happens as you're dealing with negative numbers. So whenever we multiply or divide by a negative, we have to also change this sign. So almost everything else that you do with inequalities is going to be exactly the same as you do with an equation, except for when you multiply or divide by a negative number, you also need to flip the sign to keep it unbalanced. Now, just a quick rule of thought, we get less than and greater than, and if that's the case, we're not interested in where they're equal at all. We will use that equation, or we'll manipulate it like an equation just to see, for example, where it's less than. So like before, we had x is less than 5. We're not interested anymore with x equal to 5 because that doesn't fit this equation. 5 is not less than 5. So we're only interested in everything below 5, but 4.999999 now fits the equation. But these here, when we have less than or equal to or greater than or equal to, we are also interested in where they're equal. So we're going to take it where it's equal and everything below it if it's less than, or where it's equal to and everything above it if it's greater than. But again, we're going to solve it the same way we will with an equality, with an equation, except for when we multiply or divide by a negative number. So I hope that helps. Please like and subscribe. Pass this information on to anyone that it might be useful for, and thanks for watching.